We now look at the concept of the mean of a random variable, or the expectation. So the word expectation or expected value or the mean are the same in meaning for us. So if I look at the random variable x, which denotes the number of heads tossed in a single toss of a coin, this probability mass function is listed there below. X takes the value of 0, 1, probability is a 0.5, 0.5. Now, let me think of it this way. If I take a look at 10 tosses of a coin, and I'm looking at the number of heads, and I want the expected or the average number of heads. Well, the probability of heads is a half, then I expect half of those particular tosses to be heads. So I'm expecting half of these to be heads. In 100 tosses, I get half, 50 heads. So in this case, we formalize this concept as follows. If I have one toss of a coin, then what I do is, it's not just the values that are important, but also the probabilities. So I'll weight the values of the probabilities. Those that have a higher probability will be weighted more highly. And so I get a weighted average here in some way of the random variable itself. So the mean essentially is found by the value of the random variable times the probability, value times probability, and I add that all up. In this case then, for x as the number of heads in one toss of a coin, the mean or the E of x is 0 times 0.5 plus 1 times 0.5, that's 0.5. In other words, that means in a long run, and as an average, in the long run, I will get half of the tosses giving me heads. That's what this means. In a single toss, of course, I don't get a half a head, but it means in a long run, half of the tosses will be heads. So we can write this essentially as mean of x. We define for a random variable x the mean or expected value of x as, give it the symbol ex this way, or sometimes we write the thing also as mu. Sometimes mu of x here, if it's not clear, we want to make sure it's x we relate to. It's again, this means x times the probabilities that x has, and this means sum. This is sigma, the Greek letter sigma, sum, and that means over all the values of x. So it essentially writes down in formal language what we just did here. Take the value of x times the probability, value of x times probability, and add them all up. That's all that's happening here. If I want the mean of something else like e of x squared, something squared here, and all that happens is that gets squared and the same process happens, and we'll see an example of that afterwards. So e of x, or the mean, is the theoretical mean and can be thought again as a long-term or long-run average of an infinitely large number of trials here. The example here, I've got my random variable x here with the values and probabilities. I want e of x and e of x squared. So e of x very fast comes down to just simply -1, sorry. So it's -1 times 0 plus 0 times 0.2. Oops, sorry, let me change this, excuse me. I'm making some errors today. So it's -1 times 0.1 plus 0 times 0.2 plus 1 times 0.3 and plus 2 times 0.4. So that will come to, that's -0.1, that's a 0. 0.3 plus 0.8 is, so that comes to 1. If I look at e of x squared, then the number gets squared first. So -1 squared times 0.1, 0 squared times 0.2, 1 squared times 0.3, and 2 squared times 0.4. So the numbers here, that's -1 squared is a 1, so this is 0.1 over here. That is a 0. 1 squared is still 1, so that's 0.3. And 2 squared is 4, so that's going to be 1.6. And this comes to 2. So you can see the process of how this works. Usually we are only interested in working out e of x or e of x squared. As I said earlier, We also use the mu, the symbol mu, the Greek letter mu for mean. In general, e of x squared is not the same as e of x whole squared. So if I square before I take the mean, it's not the same as taking the mean and then squaring afterwards. Properties of expectations. If I take a look at a constant random variable that takes only one value, its mean is just c itself. For any constants a and b, the mean will essentially work in the same linear fashion. So if I take a look at ax plus b and work out its mean, it's the same as finding the mean first and then using the same equation, a times the mean plus b. And if I subtract the mean first, then what I'm left with is something that's got 0 mean. So all I'm doing here is, if from x I subtract the mean to start off with, the resulting thing will have mean 0. And that's not so hard to show. So if I take a look at a simple case here, where x takes values 0 and 1 with probabilities a half each, I know here from the previous examples that e of x works out to be a half. If I take a look at x minus a half, then the values here are going to be negative a half and a half, and the probabilities are still half and a half. And you can see here the mean of this is going to be equal to 0. Because negative half times a half plus a half times a half gives me 0. So that times that plus that times that gives me 0. So that holds very clearly, and this is a nice, neat way of looking at things sometimes. We'll look at variance afterwards.